Okay, so was this the homework question? The very first one? Okay. Yes? Question 5. Oh, here, yes. And as I was doing these questions, I felt that actually I can improve my presentation. If you recall always my presentation, I always keep, I try to do everything in one line. So I do the calculation for the cross-sectional area, then immediately I'll multiply by 30 for the thickness. Then for the surface area, I will actually redo the same calculation for the cross-sectional area, multiply by 2, add the perimeter times the thickness. Then I thought about it, maybe I should present my work, maybe I can consider presenting my work this way. Since I know the cross-sectional area is going to be used twice. First, it is going to be used in a volume. Let's multiply that by the thickness, we get an answer. Then in the surface area, we're going to multiply that by 2. So maybe by doing this, I can save some calculation and save some writing also. So I think I'll do this in future now. And I hope you, as you do your mathematics, you also keep thinking about how you can improve your presentation. Sometimes I learn things from you guys also. For example, the conversion from square meters to square centimeters, square meters, I realized from you guys that actually I can just multiply or divide by 100 square. And from then on, I keep doing that already. So thank you guys for teaching me that. So keep thinking about how you can improve your own presentation. This is how I'll do it from now on. I'll write down the cross-sectional area, then I'll just quote the value in the next two calculations. Okay? So in my calculation of volume, it is our cross-sectional area times the thickness. Get the value. In the surface area, we're going to take the same cross-sectional area, the exact same one, we're going to multiply by 2. Because there's a front and there is a back. Then we're going to multiply, we're going to add that to this is the perimeter of the cross-sectional area. And again over here, this is the thickness. And you get the answer, 3385. I think there was an error in the value that I gave yesterday, 3085. Yeah. So some of you have pointed out to me that, hey, that one doesn't seem correct. And I appreciate that coming from you all. I think this particular diagram could have been drawn better, or more information could have been given, because it's a little tiny, but we have to see that this 8 plus 10 is actually the perpendicular height, the vertical height of this parallelogram if we choose 25 as the base. Okay, then in this triangle that is cut off, it has a base of 10. We got 10 by taking 25 minus 15. So it's got a base of 10. And its corresponding perpendicular height will be this 8 over here. So you can indicate all these right angles to help yourself when you are doing your revision. Okay, do you need more time for this? For your corrections? Okay, I'll give you about 30 more seconds. So as mentioned, my format is now going to be like this. I will always find the cross-sectional area first. So the cross-sectional area is made out of a trapezium plus a semicircle. So putting that all in, and you'll notice my cross-sectional area, it includes a 49 over 2 pi. You might be tempted to actually find out the value. 108 plus fraction 49 pi over 2. You might be tempted to write down this value, 184.969. So here, 184.969. Nothing wrong with that. But do note that whatever I just written down in blue, whatever my calculator is giving me is not exact. Because of the pi over here. Pi is irrational. It goes on forever and ever without any pattern. So, by keeping it as 108 plus 49 over 2 times pi, this will be exact. But it might be a little troublesome when you key in later on. So your choice, make the decision yourself. Blue is fine, more SF is better. Exact value, even better. So here, volume, I'm going to copy the entire cross-sectional area down. Only at this stage. Then I will key in to my calculator and I will just multiply this by 30. So that gives me 5549 point blah blah blah. I always show my 5SF first before I round off to 3SF. This is a must in case you need this value for subsequent parts. For example, they may have a part E. If 1 cubic centimeter of this material costs $3, how much will this figure cost? So you need to take the volume multiplied by the cost, isn't it? When you take the volume multiplied by the cost, if you choose to use the 3SF volume, then you're losing your accuracy already. You have to take your 5SF volume in order to do the calculation. And imagine if you are lazy, you don't write this down, then when you go on to part E, then you realize, oh, Mr. Wong said I cannot use the 3SF, I need to use the 5SF. Then you have to take out a calculator and start calculating again. Waste time. Might as well make it a habit always to write on the 5SF before you round off to 3SF. Next, surface area, 2 times of the cross-sectional area. So it's 2 times cross-sectional area plus, this is the perimeter of cross-sectional area. And we multiply by the thickness. So again, you notice I key in the exact value. I didn't use any 5SF, 3SF, although 5SF is still okay. Okay. Just later on, your final value will not be as exact as mine. But after rounding up to 3SF, we should be very close to each other. So this will be 2170 square centimeters. Use this opportunity to keep revising on your significant figures, how you round them off. Because you're never going to be able to escape from them even after secondary school. Okay, part C. Exterior area to be painted. Cost $48.50 per square meter. So how much will it cost for painting this object? So definitely we need the area. So earlier on, area, look, I've got my 5SF. And that is what I'm going to use for my calculation, for my conversion. If you were to use 2170 square centimeters for part C, there is a chance that your final answer will be wrong. Or rather, not what we want it to be. Not as precise, not as accurate. So we're doing the conversion. So again, I'm using what your class has taught me. I will divide by 100 square. Very convenient, very quick. Get the value in square meters. Now, presentation over here. Please do not write 1 square meter equals to 48.50. Because this is area. This over here is money. Area is not equal to money, they are different. You should present it as 1 square meter costs $48.50. That makes more sense. Okay, they cannot be equal. You are also not in primary school anymore. You shouldn't be writing 1 square meter arrow, $48.50. What does the arrow mean? The arrow has a meaning in mathematics. It is not meant to be used this way. In primary school, your teachers probably allowed it to make things easier for you. But you're no longer in primary school. So you have to learn what is correct. So since 1 square meter costs this value, 0.21697 square meters, multiply, get the answer, $10 and $5.523. $10.523. However, we're dealing with money. We cannot have $0.523. What is the smallest unit of money we have in Singapore? Smallest value? 5 cents? Is it 5 cents? Actually, you're right. The circulation is 5 cents. You hardly see a 1 cent coin anymore. But are you aware that a 1 cent coin exists? Yeah, it exists. It's just that it is too troublesome to use already. Such that a few years ago, government decided that we're not going to continue making these 1 cent coins anymore. In future, we're going to keep it to 5 cents. But you know that in mathematics, we always leave it to 2 decimal places. Okay? So in this case, you'll be 10.52. But if this is a real life situation, when you go and pay money, suppose the bill comes out to be 10.52. How much are you going to pay? 10.5? Is it 50 or 55? Suppose you go out and eat, then the bill is $10.52. How much do they expect you to pay? $10.50 or $10.55? 55? If my food costs $10.52, they charge me $10.55, I'll be very unhappy. Will you be unhappy? Because they take away another 3 cents from you for nothing, right? So they'll round it down to $10.52. $10.50. Okay? What happens if the price, suppose you go and have pizza, and it comes out to be $10.58? What will they charge you? Will they charge you $10.55 or will they charge you $10.60? If they charge you $10.60, will you be unhappy? No, because 2 cents doesn't matter to you, is it? I think they will charge you $10.55. They will tend to. Aloysius, you disagree? Do you agree or disagree? Really? Really? They round it up? Okay, I should pay more attention to the receipts that I get from now on. I always thought they round down. But what if I complain? Hey, why you charge me extra money? Okay, I'll take a closer look at my receipts from now on. Okay, but for mathematics, for our syllabus, just leave it to 2 decimal place. Okay, for money. Okay, next. Was this also a homework question? Okay, now we have a cake. 1/8 of the cake was cut out to create a design. What kind of design looks like this? And find the volume of the remaining cake. So you have to recognize that this is still a prism. If I were to share this piece of cake with 1,000 people, everybody must get the same shape, same size. Then they will get this Pac-Man shape. And this is our cross-sectional area. So cross-sectional area, 7 out of 8 of a full circle. In this case, the value of pi, they want us to use 22/7. Is 22/7 exact? No. Listen carefully. Is this an exact number, 22/7? It is an exact number, but is it the exact value of pi? No, there's a difference in the questioning. So we know that whatever we do from here, if we use 22/7, our final answer is actually an estimate only. Okay, but this value 22/7 is an exact number. Now, cross-sectional area, 7 out of 8 of a circle. The area of a circle is pi r squared. Okay, so we key in the value of 22/7, we get an exact value of 539 square centimeters. There is no need to round off this value. Okay, because we are told to use 22/7. Similarly, if you are told to use 3.14 or 3.142, you don't have to round off, because they gave you an exact value of pi to use. You round off only when you're using your calculator value of pi, which goes on forever and ever. Okay, see the difference? Now, from there on, we multiply by the thickness. Oh, it is 12 cm thick. Get the volume. Okay, now for our understanding, 6468 cubic centimeters. Is this an exact value? Did I do any rounding off? No, I didn't do any rounding off. This is an exact value. However, is this an accurate value of the volume? Is it an accurate value of the volume? No, it is not. Why isn't it accurate? I didn't do any rounding off. Why do you say it's not accurate? So the reason came from the value of pi. over here they are already using an inaccurate value. And therefore, this 6468, although is an exact number, it is not the actual value of the volume of the cake. So this is the understanding behind all these. So going by this logic, I hope the following statement doesn't confuse you. Going by the following logic, is it safe for us to therefore say, hey, since 6468 is not exact, since 6468 is not the actual volume, how about I round it off to become 6470 cubic centimeter? After all, this answer is not the actual answer already. How about I round it off? Generally, I think teachers will accept this also. Using that logic, since this wasn't exact, might as well round it off. Okay? So we don't really have a hard and fast rule for every single situation. As long as you're able to justify why you decide to round off, I think it is fair on your end to round off. Okay? But I'm telling you, there's no need. But if you do round off, it also is okay, since 22/7 is already rounded off, since it is already an estimate. So same logic for part B. Find the total surface area. So we take the same surface area that we found earlier on, 539, multiply by 2, and this must be our parameter of cross-sectional area. And we multiply by the thickness again. So from here, if you round it off to 2340 square centimeters, I will say it is fine. Okay? But you must understand why I'm saying these things. Anybody needs more time for this page, for this question? Raise a non-writing hand.